in this book, he shows the... Actually, I can do this time better. Copy. I mentioned last time that I don't know how to pronounce his name, Eratosthenes. Remember I mentioned that his friend said there's a well 25 stadies, miles, south of here, and on Midsummer Day, the light goes straight down the well. That's this one. Well, he went, stadies turns out to be 925 kilometers, and he put a stick in the ground on Midsummer's Day, and he looked at the angle. And from that angle, he was able to figure out how far away the sun was. He then took the sun and used it to determine the moon. So now you've got the sun's distance. You also have how big the sun is in the sky. So you've got the distance and how big it is, and angularly speaking, you can actually turn that angle into a distance because you've got this distance, and using those similar triangles, you can say, oh, well, the sun is not only this distance away from me, but it's this big. Then, during an eclipse, he timed it from when the moon was just at the edge of an eclipse. And then he timed it as it went through the moon being completely blocked, and then the moon showing up on the other side. And he used that timing and the other calculations that he'd made to determine the diameter of the moon. And then again, with using similar triangles, you can get the distance to the moon. And as I mentioned last time, his circumference of the Earth based on the first thing was off. It was 46,000 miles. So what? That's so close compared to, 25,000 miles circumference that, it's not an order of magnitude off. It's off by an order of 2. And as scientific measurements go, when you're using something as crude as this, that is phenomenal. His calculation gave the diameter of the moon is 3,200 kilometers, and the modern measurements are 3,480. That's just amazingly accurate further. And remember, this is 3,000 years ago? I mean, a long time ago. Then he used the same math to get the distance to the sun. And on the back of it, it shows that you can make a guesstimate yourself. Why? It's that similar triangle thing again. The next time there's a full moon out, extend your hand until your thumbnail just obliterates the moon. And then take the measurement from your thumbnail to your eye and measure how big your thumbnail is, and you've got the two similar triangles. And you yourself can determine the diameter of the moon. I thought that was just amazing. And I enjoy going back to that with every class.
How long ago was that?
It was Eratosthenes. It was in the era of Greek stuff, 2,500 years ago. There we go. That was Pythagoras and Eratosthenes. Yeah, Eratosthenes did it 2,300 years ago. Long time ago. No telescopes. Didn't even have the things that Tycho Brahe used, which was a 40-foot long straight edge, essentially, to calculate things. I just think, let's see. I heard a phrase on the radio the other day. It's not the result that gets you the Nobel Prize. It's the question. And this guy clearly had, you know, all of his neurons working when he realized, I know geometry really well, 200 years after Pythagoras, and I can use it to do these things. I obviously find that fascinating. Okay. Does anybody have any more questions? Sorry?
Is that typical of knowledge
in certain spheres? It makes you a celebrity if you ask the right question and somebody can answer it. There was a famous mathematician named Erdős, E-R-D, who knows what squiggle above it, S. He never had a home. He never lived at any specific location. Why? He would drop in on his mathematical friends and his greeting would be, "My mind is open." He was an oddball, but the thing is, he could help people in mathematics in diverse subcategories. So he might help somebody with the topological problem. He might help somebody with a completely different mathematical problem that doesn't have anything to do with that. And it's apparent if you read, there's two books that I've read about him. One is called My Mind is Open or something close to that. And the other one is a biography. And
there are some...
He was a guy who just was wired for math.
Do you think he was a savant?
No, because he had some... savants we usually think of as people who are very limited but have one special ability. No. He could, you know, he was sociable and he had other things, but his math was stunning. Okay, that was earth sciences, plate tectonics, continental drift, and so on. Any questions on those from anybody in the audience?
Yeah, well, we were talking about those islands, so go back there.
Right.
Australia is so different. I was there, you know, last year, and so different than this whole thing. Was that an island really by itself?
Well, no. It's separated from it and Indonesia, kind of separated and fragmented off of the southern Asia. But it did so long ago, and it only had, its only mammals were marsupials to begin with. So it just was the happenstance that the marsupials went into Australia. They took over all the niches of the non-marsupial mammals. There's even a marsupial wolf in ancient times in Australia.
And the other question I have is, if all those land masses were together on one side, there was an ocean on the other side apparently, then this turning of the world must have been kind of wiggly.
Well, no, it depends. The thing, when I say to one landmass, it's a landmass that looks funny. Okay, it's connected, but it's more like, you know, this thing's here and that thing's there and that thing's there, and
I see.
It's not just everything's connected in a circle.
Yeah.
All I meant was that they were connected in some fashion. There was a land bridge across which animals and plants could go. Oops, like that. So that an animal here could go here or could go over there. But it was a very long time ago. I can't give you a date.